All right, so this is the paper that we're starting from 1st June 2023, paper 3, variant 2. This is the first paper that we will be looking at, difficult questions from this paper, and then paper 3 after that. Okay, make sure that you have responded to the poll already. Let me have a look at that quickly. Okay, so from the first paper, it's question number 4, 5, 8, and 11. That's these are the questions that most people have voted for. We'll have a look at 7 as well. If there's a specific part that you have problems in, please let me know in the chat box as well. If there's a specific part that you want me to do from question number 7. The rest of them, let's have a look at them quickly. May, June 2023, paper 3, variant 2. This is the one that we are going to start from. Okay, so let's have a look at these questions. We have this inequality first of all, then this log question, then this complex number problem, which most of you are saying you're okay with. Okay, so this is the first question that most of you have asked about. Question number 4. Yeah, let's start with this one. It says, solve this equation. Solve the equation 2 cos x minus cos of half x equals 1 for x between 0 and 2 pi. All right, we want to solve this equation. Now, how do we do this? You see, you've got two different types of angles. Remember, whenever we're solving trigonometric equations, we want one single type of function and one single type of angle. So only one of sine, cos, and tan, and only one type of angle. Now, in both of them, we've got cos. But the problem is that the angles are different. This is half x, this is x, right? Now, what's half x? Do you know about any identity that you can use here for half x? There's a double angle identity, not a half angle identity, but what you can do is, you can actually use that. Remember, there are 3 forms of this identity that are given in the formula sheet. Cos 2a, that can be written as cos square a minus sine square a. And there are 2 other forms, 2 cos square a minus 1 and 1 minus 2 sine square a. All right, these are 3 different forms that we've got for this double angle identity for cos. Now, if the angle that you want to expand, I'm sorry, go back there. Okay. If this is the angle instead, half x, and you want to simplify this somehow, there could be 2 ways of thinking about this. One way could be that we convert x to half x as well. In fact, I think that will be easier. Otherwise, we'll have square roots involved. Yeah, so let's do this. Since we want only one type of angle, we've got x here and half x here. What you can do is, you can convert everything to half x, the smaller angle. Just like if this equation was 2 cos 2x minus cos of x equals 1, what you would do would be, you would use the double angle identity for cos and convert this to perhaps 2 cos square x minus this part. And then we'll have x here and x here. So the double angle identity could be simplified to, just this part. Now, similarly, here what we've got is, we've got an x angle and a half x angle. What we can do is, we can convert this bigger angle to the smaller angle somehow. What we can do for that is, we can use this double angle identity to convert x to half x somehow. How can we do that? First of all, let's choose one of these 3 identities that we're going to be using here. We want everything to be in terms of cos, so it's going to be better that we use this form that has only cos on the right side. Otherwise, the first form has cos and sine both, the second has cos only, and the third has sine only. Let's choose the one that only has cos. So let's focus on this one. Let's focus on this particular form, that's 2 cos square a minus 1. Now, using this, what we can do is, we can convert cos of x to cos of half x somehow. Let's see how we can do that. If on the left side we had cos of x, We could actually write it as something like this. We could say, since on the left side here, the angle is 2a, and on the right side, that angle is becoming a, what that means is whatever the angle is on the left side, on the right side, it becomes half of that. So if we had cos of x on the left side, what would you have on the right side if you were to expand it? You would get something like this. You would say this is 2 cos square, half of this angle. What's half of x? Half of x is x over 2, and then minus 1. So what we can do is we can convert cos x to this form using this double angle identity. So let me repeat what we've done is we're saying in the double angle identity for cos here, on the left side, whatever angle we've got, on the right side, the angle is just half of that. If we had x on the left side, on the right side, half of that would be x over 2. When we use that, the benefit of doing that would be that we would have half x in this first term as well, and all the angles would be the same. And then we can just solve it like a quadratic and see what comes after that. Let me actually input this value first of all. In place of cos x, let me just input this thing, what I've written on the right side here, and see what that gives us. We've got cos square of x over 2 here. Let me put that here. Cos x can be written as this thing. So it becomes 2 into, this 2 outside remains as this. Inside you've got 2 cos square x over 2, or you can also write that as half x minus 1. And then this term as it is, which is minus cos of half x. And on the right side, you've got 1. This is the equation that you get after simplification. And let's multiply 2 inside here. That gives you 4 cos square half x minus 2 minus cos of half x. Let's bring that 1 to the left side as well. And we get minus 1 equals 0 here. Let's simplify this further. And we get a quadratic equation that looks like this. 4 cos square half x minus cos of half x minus 3 equals 0. And what we can do now is we can use a substitution, right? This is the quadratic form. We can use a substitution. We can say, let this thing, cos of half x, be another variable. Let's say u equals cos of half x. And now this equation can be written as 4u squared minus u minus 3 equals 0. It's a quadratic equation. You can solve it like a quadratic. You'll get some values for u. Once you've got the values for u, you put the substitution back after that and solve it like a trigonometric equation. So we've got this quadratic. How do we solve this? Can we factorize this? This can be written as minus 4u plus 3u minus 3 equals 0. When we break the middle term, we take 4u common, and the factors are going to be 4u plus 3 and u minus 1, right? These are the two factors that we get. And that means u is either equal to minus 3 over 4 or u is equal to 1. Now you put that substitution back. You say either cos of half x equals minus 3 over 4 or cos of half x equals equals 1. These are the two values that we're getting for cos of half x. And now we can solve it, figure out what are the possible values for x from this. Now, how do you solve equations like these? When you have cos of half x here. Remember the interval that we're given for x, that's from 0 to 2 pi. So the x values are supposed to be between 0 and 2 pi. Let's write that down here. If x is between 0 and 2 pi, what about half x? What should half x be between? We divide the whole thing by 2. And that gives us that half x is supposed to be between 0 and pi. That's the interval that we've got for the angle half x. If you want to use a substitution here, some of you, in fact, it's easier to use a substitution here. If you want to do that, you can do that. You can use, let's say, let a equals half x. Here as well, let a equals half x. And then solve it in terms of a. And at the end, you could say, in place of a, put half x. Or you can do it directly. It works both ways. It's your choice, however you want to do it. But what happens is when you adjust the interval becomes half x between 0 and pi. All right. And now let's find the basic angle. Let's find the basic angle from the first thing and the basic angle from the second thing. Cos alpha equals 3 over 4. You get a basic angle from here. You can see what that turns out to be. Make sure your calculator is in radian mode. If you convert that, radian cos inverse of 3/4. That's giving me 0.7227 in the first case. If you think of the quadrants now, cos is negative here. Where is cos negative? It's negative in second quadrant or in the third quadrant. The interval that we have is from 0 to pi. Keep in mind, this is the interval that we are going to be using for half x. That's 0 and pi. That means third quadrant is not possible. We only have a value on the second quadrant, and that's going to be this angle alpha. So what does that mean? What's half x equal to then? The angle that we get is this one. What's this angle? Pi minus 0.7227, and we get a value of x from this, pi minus 0.7227 multiplied by 2, and that will be your first value for x, which is 4.8377. If you round it off, that becomes 4.84. That's one possible value of x that I'm getting from this. And similarly, you find the basic angle here. You say cos alpha equals 1. You can think of graph as well if you want, but let's find the basic angle. Let's see what that turns out to be. Cos inverse of 1, that's giving me 0. Cos is 1 when the angle is 0, right? So within this interval, where is that going to be? Let's think about this. Cos is positive here. It's positive in the first quadrant and in the fourth quadrant. Basic angle of 0 could either be on this line here or on this line here. Which one do we choose? The one on the right side, right? Because here we've got both ticks. So this is the angle that we choose here. What's that angle? That's 0. So we get half x equals 0 from this. And the value of x that we get from this one is 0. These are the two possible values of x that we get. X is either equal to 0 or it's equal to 4.84. These are the two values of x that we get. Does that make sense to everyone? Any problem with this? So the tricky part here, the tricky bit was how to use the double angle identity here to convert cos x to cos of half x. You think of it like this, that x is basically twice of half x, right? 2 times half x. So for that, we basically use this double angle identity. Since cos of 2a can be written as 2 cos square a minus 1, if we have x on the left side, on the right side, it will become x over 2 or half x. And that is what you can use to convert cos x to cos of half x as well. And then it just becomes a simple quadratic equation like this. You solve it like a quadratic, put that substitution back at the end, and find the values of x that we get from that. Is that okay to everyone? Any problems?
Sir,
Yes.
sir, the power of x is 1 in the above equation. How can we convert it to quadratic?
It's cos square.
Sir, like if x, the power of x was 2 inside and cos was 1 outside, can we still convert it to quadratic?
No. So what we're doing is we have 4 cos. So the actual form is 4 cos half x whole squared minus cos of half x minus 3. This is what the form is. Now, you have a square term, you have a power 1 term, and you have a constant. So whatever is inside here, inside the power, this is power 2, this is power 1. So that's basically a quadratic equation.
Okay,
Right?
sir.
We've done this. Yes.
Yes.
It's just the half x thing that's confusing you, but we've done this before as well. If you have 4 cos square x, you get something like this, minus cos x minus 3. It's clear that you would be converting it to quadratic. It's just that in place of x, we have half x there, but that does not make any difference. It can still be solved as a quadratic.
Okay,
Okay.
sir.
Yes, Faizan? Faizan? You were saying something? I can't hear you. Okay, so that was one question that you were asking, question number 4 from this paper. Now the next one is question number 5. Let's have a look at that. question number 5 from this paper, right? Yeah, question number 5. Let's try that. It says the complex number 2 plus y iota is denoted by a, where y is a real number and y is less than 0. It's given that f of a equals a cube minus a squared minus 2a. Find a simplified expression for f of a in terms of y. Okay, so how do we do this? First of all, we are given that a equals 2 plus y iota, right? This is the complex number that's denoted by a. A equals 2 plus y iota. Y is a real number and y is less than 0. Now that's important. The imaginary part, that is negative, right? The y value is supposed to be negative at the end. Okay. Now it's given that f of a equals this. Find a simplified expression for f of a in terms of y. Now, how do we do this? F of a, that equals this. And that's a cube minus a squared minus 2. All we have to do is put this thing inside here. It becomes 2 plus y iota whole cube plus 2 plus y iota whole squared minus 2 times a. You just need to simplify this. Okay, in place of a here as well, we should input 2 plus y iota. Now that's this algebraic simplification. How do you expand this? 2 plus y iota whole cube. You can either use binomial for this if you want. If not, you can write it like this. 2 plus y iota squared into 2 plus y iota, and that's also okay. Or you can use binomial expansion formula, the paper 1 formula, to expand this, and that will work as well. But let's do it like this. 2 plus y iota whole squared, that means a plus b whole squared. How do you expand that? A plus b whole squared is a squared plus 2ab plus b squared. Let's expand it like that. A squared, that means 2 squared, that's 4, plus 2 into y iota, that's 4y iota, plus y iota whole squared. What does that become? Y squared iota squared. All right. Then we have minus 2 into 2, that becomes minus 4 minus 2y iota. This is what you get when you simplify this expression outside. Okay. So we've evaluated the square. This is what the square turns out to be. And now, what about the cube? The square that we have evaluated, we can use the square to expand that cube thing as well. Let's simplify this part first. When we simplify this, this is going to become 4 plus 4y iota. Iota squared is negative 1. So it becomes plus y squared into minus 1. This is what we can input here in place of this square thing, right? Because we have evaluated the square already. Let's not do that work again. Let's put this whole thing here directly. What's that? That is 4 plus 4y iota minus y squared. This is the square bit. Now we multiply this by 2 plus y iota. So we've got 2 plus y iota here. And now let's simplify this and see what we get. 4 into 2, we have to multiply every term in the first bracket with every term in the second bracket. What do we get for that? 4 into 2, that's 8. 4 into y iota, that's 4y iota. 4y iota into 2, that's 8y iota. 4y iota into y iota. What does that become? That becomes 4y squared iota squared. Now, that's a lot of terms, so you have to be careful about careless errors. Y squared into 2, what does that become? That becomes minus 2y squared, and then y squared into this thing, that is minus y cube iota. This is the expansion of this thing. Okay, this is what I'm getting. Now, let's simplify the rest of it. That becomes 4 plus 4y iota minus y squared minus 4 minus 2y iota. Okay, now what are the constant terms? In fact, let's simplify this a bit first. It becomes 8 plus 4y iota. Just write everything down first. Then iota squared is negative 1. So this becomes minus 4y squared. Then you have minus 2y squared minus y cube iota plus 4 plus 4y iota. minus y squared minus 4 minus 2 y iota. Now, let's look for the like terms. We've got a constant here, we've got another constant here, and we've got another constant here. What do we get from these constants? 4 and minus 4, they get cancelled, and I'm left with 8 from this. Okay, again, look out for careless errors. Then there was a negative sign between what? Okay, I'm sorry, let me check again. There's no cube. Why is there no cube? Because there's y squared here, and this is y iota, so that becomes y squared into y. That's cube. No, there is a cube there. There was a negative sign between terms at the top. Okay, let me see. Okay, yeah. Thank you for that. There was a negative sign here. This was outside, this was negative. That's correct. That means this is also negative. So then this becomes minus 4 iota, and then minus into minus, that's plus y squared. So that means this term is negative. This is minus, and this is going to be minus as well, and this is going to be plus. Okay, I hope that makes it correct now. So we've got minus 4 here. These terms cancel out, and we get 0 from them. Okay, what about iota terms? Iota terms are these. Let's highlight them. We've got 4 by iota, 8 by iota, and we've got this term that has an iota with it, another term that has an iota with it, another term that has an iota with it. Okay, so that gives us 4 by iota, 8 by iota, that's 12 by iota, minus 4 and minus 2, that's 6 by iota. That's what I'm getting from this. So you've got 6 by iota, and then this term is left. That is just minus y cube iota. Okay, what are the remaining terms now? Minus 4y squared, minus 2y squared, plus y squared. What does that become? That becomes minus 4, minus 2, and plus 1. That's minus 5. That's minus 5y squared. They wanted us to write this in simplified form. You can write it like this, or if you want to write the real term separate, imaginary term separate, generally what we do is we write the real term first. We can write this first, and that becomes minus 5y squared, and then imaginary term together, the whole thing that has iota with it together. So this thing could be written as 6y minus y cubed into iota. But it's not necessary to write it like this. You can leave it like this as well, and that's perfectly okay, because they just want a simplified expression in terms of y, and this would also be acceptable. Okay, that's the first part. It's just about making sure that you're not doing any careless errors and you're careful about plus minus signs. Okay, that's what you get in the first part. Ferdinand, are you asking about this particular question? Or is it about something else? Which question are you talking about? The symbols? Which symbols? So this is A. They're saying A equals 2 plus y iota. Y is a real number. So basically, you've got y iota. The number that you have with iota, they're saying that number has to be a real number. Okay, that this number y has to be a real number, and that number has to be less than 0. So whatever number you have with iota, they're saying that number has to be negative. That's what they're saying here. And then we just have a function, f of a equals this. They're saying this is how a function is defined, just like you have f of x, so you have f of a, right? It's just a different letter that they're using. And we have to find an expression for f of a in terms of y. Now, since we know a equals 2 plus y iota, we can just input 2 plus y iota in place of a here, and then simplify everything. Okay, that's the first part. Now, the second part says, okay, so maybe you're asking about the second part. What does this notation mean? Okay, so now it says, given that RE of f of a is equal to minus 20, find argument of a. Now, what does this thing mean? RE stands for real part of f of a. This means real part of f of a. This is what f of a has turned out to be. F of a equals minus 5y squared plus 6y minus y cubed into iota. They're saying real part of f of a is equal to minus 20. What's the real part? Real part is whatever does not have iota with it. So minus 5y squared, that is the real part. That's the real part of f of a. Okay? They're saying that is supposed to be equal to minus 20. So that means minus 5y squared, that equals minus 20. We just equate the real part of f of a to minus 20. And now we solve this equation. We get y squared equals minus 20 over minus 5. That will be 4. Now we take square root on both sides. When we take square root, we have to put plus minus. So we have y equals plus 2 or y equals minus 2. But now we should be reminded of the condition that's given in the question that says y is less than 0. Since y is less than 0, that means this one is not possible. Y cannot be positive. Y has to be negative. The value of y is therefore negative 2. Y equals negative 2. Now that we know the value of y is negative 2, what we've got to do is we've got to find the argument of a. How do you find the argument of a? Let's write the number, the complex number a now. What was the complex number a? That was 2 plus y iota. 2 plus y iota. If y equals minus 2, it becomes 2 minus 2 iota. That's what the complex number a is. We need to find the argument of this complex number. How do you do that? In which quadrant is this going to be? Real part is positive and the imaginary part is negative. Where is this going to be? In which quadrant is this going to be? It's going to be in the fourth quadrant. It's going to be in the fourth quadrant. So basically, it's going to be right here, such that we've got 2 here and we've got 2 here, minus 2 here. 2 minus 2 iota. This is where the complex number a is going to be. We need to find the argument of this. What's the argument? This is going to be the argument. We can find the basic angle and then write the argument in negative. Remember, in third and fourth quadrants, we write argument as a negative number from the negative side, from the clockwise side. So what do we get from this? Let's figure this out. You can write it directly as well. There's no working that needs to be shown here because some of you would remember whenever both the coordinates are both the real part and imaginary part, they are equal to each other. The angle is supposed to be 45 degrees or 5 over 4, right? It's a gradient minus 1 line that has an angle of 5 over 4, 45 degrees. Or if you want to show working, you can do that. This is how you would do it. You would say the basic angle turns out to be 2 over 2. Tan inverse of 2 over 2. When you calculate this, this is 5 over 4. But now, since this angle pi over 4 is in the fourth quadrant, what do you say about the argument? The argument of a is therefore going to be minus pi over 4 because in the third and fourth quadrants, we write the argument as a negative number going clockwise like this. That's the argument minus pi over 4. Does that make sense to everyone? Any problem with this? No questions? For modulus, you can ignore the signs, yes. For argument, for finding the basic angle, you ignore the signs, yes. But then these signs are used to figure out which quadrant the complex number is going to be in. So in this case, since the imaginary part was negative, that is what told us that this was supposed to be in the fourth quadrant, okay? But for finding this basic angle, yes, you ignore the signs, okay? Make sense to everyone? Okay, good. So that was question number 5. The next question that we want to do is question number 7 now. 7, 8, and 11. These are 3 next questions that we want to do. But what we're going to do is we're going to have a break right now, 10-minute break from Maghrib. And then we resume and start with this question number 7 after that. In the meantime, those of you who have not had a look at the other papers, so once you're done with praying, You can have a look at the other paper as well. Let me know the questions that you're having problems in from that paper as well. Look at the poll, submit that poll. We'll have a look at that other paper later on as well. Write that down here. We have a 10-minute break. We will resume by 7:18 p.m. almost. That's 7:20. 7:20 p.m. Okay, we resume at 7:20 p.m. and then we will hopefully be done by around 8:50 almost, inshallah. Okay, we'll do the rest of the questions after that. Okay, let's have a break, 10-minute break. We come back after that. Okay, everyone, we are resuming. Let me see quickly. Everyone is back. Just post a message there. Okay, just a reminder to submit that poll if you haven't already for the second paper as well. Now we can be slightly quicker. Getting it acting as again. Let me just show that. All right, everyone. So we're resuming now. The next question that we want to do from this paper is question number 7. Okay, let's try this now. It says the equation of a curve is this. It's given here. And what we want to do is we want to show that dy over dx equals minus into 3x plus 2y divided by 2x plus 3y. Now, how do you find the derivative of a function like this? We don't have y as the subject here, right? In this function, the y is not the subject. So how do we differentiate functions like these? We have to use implicit differentiation. All right, let's use implicit differentiation to differentiate this function and see what that gives us. We've got 3x squared plus 4xy plus 3y squared equals 5. Differentiate both sides with respect to x. Right? Differentiate both sides with respect to x and see what that gives us. On the left side, when we differentiate with respect to x, what's the derivative of 3x squared? It's 6x multiplied by the derivative of x, which is just 1, plus 4 into x, y. What's the derivative of x into y? That's a product. How do you differentiate products? You have to use product rule for that. You say, let's find the derivative using this product rule. uv dash plus vu dash. U as it is, that means x as it is, into derivative of y. What's the derivative of y with respect to x? That's dy over dx. Plus v as it is, that means y as it is, into derivative of x, which is 1. That's what we get when we differentiate 4xy. And then 3y squared, what's the derivative of 3y squared? 3 remains as it is. You multiply by the power, and that becomes 6. 3 into 2, that's 6. Subtract 1 from the power, so the power becomes 1. But then you have to multiply by the derivative of y as well. What's the derivative of y? Derivative of y is dy over dx. On the right side, you've got 5. Do not forget to differentiate 5 as well. What's the derivative of 5 with respect to x? 5 is a constant. On the right side, you would have 0. This is what we get when we differentiate this. All right. And now, what about this thing that we want at the end? How do we convert it to this form? We have to simplify this and take all dy over dx terms to the left side, everything else on the right side. Let's simplify this first. That gives us 6x plus 4x into dy over dx plus 4y plus 6y into dy over dx. From the dy over dx terms, take dy over dx common, take everything else to the left, to the right side, and that will give you dy over dx multiplied by 4x plus 6y. On the right side, you would get minus 6x minus 4y, right? These remaining terms, they go to the right side. And now we divide by the other side, divide this on the other side. But before that, it might be easier if you simplify this first, because remember what you want in the end? You've got 3 and 2 here, 2 and 3 here. And in the expression that you've got, you have 6 and 4. So it might make things easier if you just divide the whole equation by 2 at this point. We can do that, right? Divide the whole equation by 2. What does that give? On the left side, we would have 4x over 2, which is 2x. 6y over 2, that's 3y. On the right side, we've got minus 3x minus 2y. Now, take this thing to the denominator on the other side and see what that gives us. dy over dx, that equals minus 3x minus 2y divided by 2x plus 3y. And now notice what you want at the end. We've got something very similar to that, not exactly that, but something very similar. In the denominator, we've got 2x plus 3y. In the numerator, they wanted 3x plus 2y. And we have minus 3x minus 2y. And they have this negative written outside. This negative is written, you see, with the whole fraction. It's not with 3 there. It's with the whole fraction. So basically, what we can do is, from the numerator, we can take negative common. And that will leave us with minus into 3x plus 2y divided by 2x plus 3y. Now, this negative can be written with the whole fraction as well. What they've done is they've written this negative sign with the whole fraction here. And then they've got 3x plus 2y divided by 2x plus 3y. And that's what you wanted to prove. This is dy over dx. Okay? That's a standard case of implicit differentiation. This is how you do it. Let's look at the next one now. The next part says, hence find the exact coordinates of the 2 points on the curve at which the tangent is parallel to y plus 2x equals 0. So tangent needs to be parallel to this equation. What's dy over dx that we have found here? Dy over dx equals minus 3x plus 2y in the numerator and 2x plus 3y in the denominator. That's the derivative. Now they want the coordinates of the 2 points on the curve at which the tangent is parallel to y plus 2x. So let's say the curve looks something like this. There is going to be some point somewhere at which they're saying the tangent is parallel to this line. What's this line? The line is y plus 2x equal to 0. What's the gradient of this line? Can we find the gradient of this line? Let's convert it to standard form. It becomes y equals minus 2x. The gradient from this turns out to be minus 2. That's the gradient of this line. And they are saying the tangent that we've got to the curve at that point, that is supposed to be parallel to this line. If that's parallel to this line, the gradient of that tangent is also supposed to be the same as the gradient of this line. Okay? So this tangent is supposed to have gradient minus 2. If the tangent has this gradient, what about the gradient of the curve at this point? That's also supposed to be negative 2. So all we've got to do is equate this derivative to minus 2. And that gives us an equation like this. Minus 2 equals minus into 3x plus 2y divided by 2x plus 3y. How minus 2? Well, that's the equation. Y equals minus 2x. The gradient of this line is minus 2. And they want that the tangent is parallel to -2. So we put the derivative of that equal to -2 as well. Okay, this is where it's coming from. Okay, now we solve this equation. Minus on both sides, that gets cancelled, right? What are we left with? We've got 2 equal to 3x plus 2y divided by this. We can multiply this on the other side, and that gives us 2 into 2x plus 3y. Let's simplify everything. 4x plus 6y equals 3x plus 2y. And that gives us x plus 4y equals 0. This is one equation that we've got. Now we need to find the values of x and y from this. How can we do that? This is one equation and we have two unknowns. We can't find two unknowns from one equation. We need another equation that connects x and y. Where will that come from? This point that they're talking about, they lie on the curve. We've got the equation of the curve as well. This is the equation of the curve. 3x squared plus 4xy plus 3y squared equals 5. Let me write that equation here. That equation is 3x squared plus 4xy plus 3y squared equals 5. This is the equation of the curve. What we can do is we can solve this equation simultaneously with the equation of the curve. Okay, we can solve these two simultaneously. How do we do that? How do we solve these two equations simultaneously? We can make either x or y the subject from this first equation. We can make x or y the subject from this equation and put that in the other equation. Either pick x the subject here or y the subject here. Okay. Let's make x the subject. That's going to make things easier because we would not have a fraction in that case. We have x equals minus 4y. We can put this thing in the other equation. Let's put that here. X equals minus 4y. What does that give us? 3 into minus 4y whole squared plus 4 into x into minus 4y. No, sorry. What am I doing? 4 into minus 4y. In place of x, we put minus 4y into y plus 3y squared equals 5. And we've got an equation that's only in terms of y. Okay. Okay, let's simplify this. 3 into 16y squared minus 4 into 4 into minus 4. What would that be? Minus 16y squared plus 3y squared equals 5. Let's simplify this. And this gives us 48y squared minus 16y squared plus 3y squared equals 5. What do we get when you simplify this? 48 minus 16, that's 32. 32 plus 3, that's 35. So that's 35y squared equals 5. And y squared equals 1 over 7. Right? Y squared turns out to be 1 over 7. What do we do now? We take square root on both sides. When we take square root, remember, we have to put plus and minus. So it becomes plus 1 over square root of 7. And y equals minus 1 over square root of 7. You can also do it like this, and that's also okay. 1 over 7, square root of that whole thing. That's also the same thing, because square root of 1 is just 1. We can write 1 outside the square root like this as well. These are two possible values of y that we're getting. And now, what about the corresponding values for x? Put them in this equation. Remember, x equals minus 4 times y. So x is going to be equal to minus 4 into 1 over under root 7. What do we get from that? Minus 4 over under root 7. Similarly, put this in the other equation, and that gives us, put the other value in the equation, and that will give you minus 4 into minus 1 over square root of 7. And you get x equals 4 over square root of 7. They were looking for they were asking for the exact coordinates of the point. So what are the coordinates of these 2 points? The coordinates of the 2 points, they turn out to be -4 over under root 7 and 1 over under root 7. And the other point turns out to be 4 over under root 7 and -1 over under root 7. Remember, they wanted exact values. They wanted exact coordinates. So you can't write decimals here. You have to leave it in exact form. And that's what you get at the end. All right, makes sense? That was question number 7. No problems with this? Can we move on?
Sir,
Yes.
sir, can't we equate the equation like can you scroll up a little bit? As sir, y plus 2x to the equation of the curve.
How do we do that?
Sir, as it is tangent.
No, but y plus 2x equals 0. And you're saying, okay, so you're saying since both of them are equal to 0, let's write the other one like this as well. 3x squared plus 4xy plus 3y squared minus 5 equals 0. You're saying equate both of them?
Yes, sir.
You can do that, but how is that going to help? You will get an equation that has both x and y. How would you solve that? You want to eliminate one of the variables. Only then you can solve the equation, right?
Sir, but I cannot understand why did you take the gradient out of it and equate it to dy by dx?
Because that's what they're saying. They're saying this point on the curve, it's supposed to have the same gradient as this line. How do you find gradient of a curve? Using derivative. We've got the derivative here. How do you find equation of this line? We can convert it to y equals mx plus c form. That's -2. What we're doing is we're saying the gradient of the curve at this point that's given by this derivative, that is supposed to equal -2. Just like if we were looking for a stationary point, for instance, how do you find stationary points on a curve? You put the derivative equal to 0 for that, don't you? For finding
Yes,
the
sir.
turning point. So it's very similar to that. Instead of 0, we are saying the derivative is supposed to be equal to -2. So we find the derivative, put that equal to -2. Right?
Okay, sir.
Okay. Yes, Mustafa, if they did not ask you for exact coordinates, you can write them in decimals as well, and that's also okay. Okay. If they don't ask you for exact answers, then you can write it in exact form or decimals. In that case, both are going to work. All right. Okay, good. Now let's move on to the next one. That was question number 7 from this paper. Let's see the next one that you're asking about, question number 8. Let's try that. Okay, question number 8 from this paper. Let's have a look at this. It says the variables x and y satisfy this differential equation. It's given that y equals 0 when x equals 1. Solve the differential equation obtaining an expression for y in terms of x. Okay, so how do we do this? How do we solve differential equations? We have to separate the variables first of all, separate y and x. We've got dy on the left side, we want y terms on the left side. Dx will go to the other side, so we want x terms on the right side. Let's see what we get from that. Let's bring the y terms to the left. So this can be written as 1 over 4 plus 9y squared. And on the right side, so on the left, we also have dy. Dx goes to the other side, and we have 1 over e raised to the power 2x plus 1 dx. Variables are separated, and now we need to integrate both sides. Integrate the left-hand side and integrate the right-hand side. Now, how do we integrate both sides? What about the left-hand side? It's a fraction. How do we integrate fractions? Remember all those rules that we have for integrating fractions. We can use the ln rule. We could use the tan inverse rule, partial fractions, splitting the numerator, quotient plus remainder over divisor in case of improper fractions. We've got all those rules that you've studied. Which one of those rules can work here? Which form is this? This is not ln form because the derivative of denominator is 18y. We can't have y in the numerator, so it's not ln form. What about tan inverse? Is it tan inverse form? You have a constant in the numerator, and in the denominator, you've got two terms, one square term and one constant term, and we have a plus between them. It's the standard tan inverse form. What's the rule that we've got for tan inverse? The rule looks like this. It's written like this in the formula sheet. If you've got x squared plus a squared in the denominator, the integral of this is given by 1 over a into tan inverse of x over a. That's the rule that you will find in the formula sheet. Let me show that to you here as well. This is the formula sheet. For integration, 1 over x squared plus a squared, integration of that is given by 1 over a into tan inverse of x over a. Right? That's the rule for integration. Now, in this case, instead of x, we've got y. That does not make any difference. We can just put y here. Right? So we can say integration of 1 over y squared plus a squared with respect to y. That will be 1 over a into tan inverse of y over a. All right. Now the problem is we need to convert it to this form. In the numerator, we already have a constant. In this case, that's 1. In the denominator, we need y square, and the coefficient of y square has to be 1. Right? The coefficient of y square has to be 1. So first of all, we need to make the coefficient of y square 1. How do we do that? In the denominator, we can take 9 common outside. So first of all, I'm going to write this in rearranged form like this. I will say this is 1 over 9y squared plus 4. Okay. I'm just writing the y term first, just to make it similar to this. And then the constant second. And now we want the coefficient of y squared to be 1. So for that, I'm going to take 9 common outside. If I take 9 common outside, what does that leave me with inside the integral in the denominator? When we take 9 common from 9y squared, that becomes y squared. When you take 9 common from 4, that gives us 4 over 9. So the coefficient of y squared has become 1 now. That is done. That part is done. Now we need this constant to be in the square form. 4 over 9. How can we write 4 over 9 in square form? We can say this is 1 over y squared. What's the under root of 4? That's 2. Under root of 9 is 3. So we can say this is 2 over 3 squared. Now this is that standard form that we were looking for. In place of a, we have 2 over 3 here. So on the right side, when we integrate it, in place of a, we are just going to in the integral, the right side is, on the right side, we're just going to replace a with 2 over 3. Let's do that. What is the integration going to be? 1 over 9 outside remains as it is. Now let's apply this rule. 1 over a, that means 1 over 2 over 3 into tan inverse of y over a. That becomes y over 2 over 3. That's the integration of this left side. Okay, we can simplify this in the next step a little. We'll do that. But the integration part is done. Okay, that's how you integrate the left hand side. Now let's come to the right hand side. How do you integrate the right hand side? We've got 1 over e raised to the power 2x plus 1. This is also a fraction, but in this case, none of the rules for fractions are going to work here. The way to integrate this is that you bring this term to the numerator. When this comes to the numerator, what is this going to look like? E raised to the power 2x plus 1 whole power minus 1. And then this minus 1 gets multiplied inside. When it gets multiplied inside, we end up getting the power equal to minus 2x minus 1. And now we need to integrate this with respect to x. E power something, how do we integrate that? We got something linear in the power, right? So we can integrate this directly. E power something remains e power that thing, e raised to power minus 2x minus 1. But then whatever comes in this place, you've got to divide by the derivative of that. What's the derivative of minus 2x minus 1? Derivative of minus 2x minus 1 is minus 2. So we divide by minus 2 because of that. That's the integration of the right-hand side. Once you're done with the integration bit, you put a plus c here as well. You put plus c on any one of the two sides. And I'm putting that on the right side here. That's the integration. Now let's simplify both sides a bit. On the right side, I've got minus 1 over 2 e raised to the power minus 2x minus 1 plus c. This is what I'm getting after integration. Now let's simplify both sides and find the value of c after that. Let's look at the term on the left side. How do we simplify this? This 3 and this 9, they can get cancelled, and we have 3 left here. And then this 3 into this 2, that's going to give me 1 over 6 outside. So we've got 1 over 6 into tan inverse of y over 2 over 3. This 3 will go to the numerator, and it becomes tan inverse of 3y over 2 on the left side. On the right side, I've got the same thing, minus 1 over 2 into e raised to the power minus 2x minus 1 plus c. And now we need to find the value of c somehow. How do you do that? You've got a point given. They've given you some value of x and y. They're saying y equals 0 when x equals 1. Let's use that to find the value of c now. Let's put y equal to 0 and x equal to 1. Let's see what we get from this. Okay. It becomes tan inverse of 3 into 0. That whole thing becomes 0. So tan inverse of 0. On the right side, we've got minus 1 over 2 into e raised to the power minus 2 into 1 minus 1 plus c. What's tan inverse of 0? Calculate that on the calculator. That will be 0. So on the left side, you've got 0. On the right side, you have minus 1 over 2 into e raised to the power minus 2 minus 1, which is minus 3. So the c value becomes 1 over 2 e raised to the power minus 3. Or we can write e in the denominator if we want as e cubed. This can also be written as 1 over 2e cubed. That is the value of c that I'm getting. Okay. Done until this point, right? We're done with integration. We started by separating variables, integrated both sides, and that's the solution. Now what we want to do is we want to make y the subject, because they said they want an expression for y in terms of x. So y needs to be made the subject. Okay, now let me write down that equation first of all. That is 1 over 6 tan inverse of 3y over 2 equals minus 1 over 2 into e raised to the power minus 2x minus 1 plus c, which is 1 over 2 e raised to the power 3. Now, how do we make y the subject after this point? There's no y on the right side. Y is only on the left side here. Okay. Let's multiply 6 on the other side first. Let's see what that gives us. That gives us tan inverse of 3y over 2. That equals minus 3e raised to the power minus 2x minus 1 plus 6 over 2 again. That will be 3 over e cubed. Let's actually bring that to the numerator again so that we don't have a fraction anymore. 3e raised to the power negative 3. That's what I end up getting. Okay. Write it like this here, 1 over 2 e raised to the power minus 3. And that becomes 3e raised to the power minus 3. I've just multiplied this 6 on the right side. Make sense until this point? Now this is tan inverse. We need to get rid of the tan inverse. This goes to the other side, and it would become 3y over 2 equals tan of minus 3e raised to the power minus 2x minus 1 plus 3e raised to the power minus 3. And that gives us y equal to, this goes to the other side, gets multiplied, 3 gets divided on the other side, and we have y equals 2 over 3 into tan of minus 3e raised to the power minus 2x minus 1 plus 3e raised to the power minus 3. This is the final result that we get from this y in terms of x. Make sense?
Sir,
Yeah.
sir, can you please tell how did you integrated 1 over e raised to power 2x plus 1?
Okay. Just give me a second. 1 over e raised to power 2x plus 1. I just took that to the numerator. It became e raised to power minus 2x minus 1. Now, what's the rule that we've got? Integration of e power x, as per the formula sheet, is just e power x. However, if there's something else instead of x here, some linear expression, what does the integral become? E raised to power ax plus b divided by the derivative of that. That's the rule that we've applied here. It was e raised to power minus 2x minus 1. That remains e raised to power minus 2x minus 1. But then we divide by the derivative of minus 2x minus 1, which is minus 2. That's minus 2 here.
Sir,
Okay.
basically, when you took e raised to power 2x plus 1 to the numerator, it became basically whole power minus 1.
Yes, and then I just
Sir,
multiplied minus.
sir,
Sorry.
if you multiplied minus 1 with e, so shouldn't e also have minus sign with it? Minus e.
What are you saying? If
Sir,
remember the whole x raised to power m, and this becomes x raised to power m, and powers just get multiplied. That's the basic indices rule. We're just multiplying the powers with them, with themselves. Huh? Why would you multiply e by minus 1? Only the powers get multiplied.
okay, sir. Okay, okay.
How did tan go to the right side? Just like if we have tan of x equals y, or let me say tan x equals 1, when tan goes to the other side, it becomes tan inverse of 1. If you want to take it back, on the other side, it becomes tan x equals 1, right? So when tan inverse goes to the other side, that becomes tan. When tan goes to the other side, that becomes tan inverse. Okay. So we had tan inverse here. It goes to the other side, on the other side, it becomes tan. All right. Okay, good. That was question number 8 from this paper. Okay, let's have a look at the last one from this paper. That's question number 11. Okay, no, there's one part left here. That's part B of this. It says state what happens to the value of y as x tends to infinity. Give your answer in an exact form. Okay. Now let's think about this. So it says y equals 2 over 3 into tan of minus 3 e raised to power minus 2x minus 1 plus 3 e raised to power minus 3. Okay, that was y in terms of x. Now, what happens when x tends to infinity? When x goes towards infinity, what happens to y? Now, one way to do problems like these is using a calculator that you input a large value for x in your calculator. For example, for 10 raised to power 10, something very large. However, the problem here is they want an exact answer. You can't get exact answer using calculators like that. Okay, so that means if they want an exact answer for this, you have to think of it logically. There's no other way to do this. Okay, so think of the logic of what happens if x becomes very large. Now think about this. As x goes to infinity, that means if x becomes very large, where is x appearing in this whole expression? X is only appearing right here. So you have to think about what is going to happen to this thing when x becomes very large. And that will make you understand what happens to this whole thing there. So let's focus on this part. E raised to power minus 2x minus 1. What is going to happen to this? E raised to power minus 2x minus 1. If x becomes very large, what happens? As x goes towards infinity. What does that mean? We are going to get e raised to power some extremely large number, but that's a negative number. E raised to power minus 2 into infinity minus 1. That basically gives you e raised to power minus infinity. E raised to power an extremely large negative number. What is that going to be? You can think of it as 1 over e raised to power infinity. So basically in the denominator, you've got a very large number. 1 over an extremely large number What's that? That is basically 0. So what happens is, when x becomes extremely large, this expression here, that goes to 0. Okay, this thing basically becomes 0. Now, when that becomes 0, what about y then? It's 2 over 3 into tan of minus 3 into 0. So that means this whole thing becomes 0. What are we left with? 3e raised to the power minus 3. This is going to be the value of y as x goes towards infinity. 2 over 3 into tan of 3e raised to the power negative 3. That's the result that you get from this. Is that okay? So you just think about what happens to this part. When x becomes very large, this part becomes 0. So that gets eliminated. And we're just left with 3e raised to the power negative 3 inside tan. And that's your final result. All good? Okay, so that was the last part of question number 8. Next we have 9. Nobody's asked about that. 10, it's about turning point and area under the graph. Okay, I hope you've attempted that and were able to do that. This is the next question that you guys are asking about, question number 11. Okay, let's start this now. It says the points Mustafa, it's not x that becomes 0. X is going towards infinity. But since we have e raised to power minus infinity, that means we're going in the denominator. Denominator is an extremely large number. This whole thing becomes 0 because of that. Okay. We need to do some practice on those questions, try to really make sense of this. So that's a standard question that comes in differential equation. You have to think about what happens to a value based on another value going towards infinity. Question number 11 says the points A and B have position vectors I plus 2j minus 2k and 2i minus j plus k respectively. The line L has this equation. Show that L does not intersect the line passing through A and B. Now that's a standard vectors question. How do you solve problems like these? You've got one line L. We have the equation of that given. This is the equation of the line L. Let's write it in column vector form to make things easier to understand. Line L has this equation. R equals 1 minus 1, 3 plus mu into 2 minus 3 and 4. This is the equation of the line L. The other line that they're talking about is the line that passes through A and B. Can we find the equation of the line that passes through A and B? Let's do that. We've got the position vectors of A and B. This is OA. Let me write this in column vector form. This will be 1, 2, minus 2. And this will be 2, minus 1, and 1. In order to write down this equation AB, we need the direction of the line AB. How do you get that? Using the vector AB. How is AB calculated? This is OB minus OA. Okay. What's that going to be? 2 minus 1, 1. Subtract from that. 1, 2, minus 2. And the vector AB turns out to be 1 minus 3 and 3. This is the vector AB. Can we write down the equation of AB now? The equation of the line AB would look like this. R equals, remember the form, A plus lambda D. They've used mu here, so we can use lambda here for this equation. A is any point that lies on the line. You could use any one of these points. You could use this or this. Both of them will work. Let's use the first one. That's 1, 2, and minus 2. So that is 1, 2, and minus 2 plus lambda into direction. This is direction vector of the line AB. That's 1 minus 3 and 3. Okay, so we've got the equations of both lines. We've got the equation of the line AB and the line L. We need to show that L does not intersect the line AB. How do you show that? It's the same process that you use for finding points of intersection of two lines. You just equate both of them, make three equations, solve two of them, put that value in the third equation. Third equation in this case will not satisfy, and that will mean that the line L does not intersect the line passing through A and B. Let's do that quickly. When we equate both of them, we would get something like this: 1 plus lambda. I'm simplifying this equation. This is the equation for the line AB. 1 plus lambda, 2 minus 3 lambda, minus 2 plus 3 lambda. Equate this to the equation of the line L. Let's simplify this as well. 1 minus 1 is 3, 2 minus 3 and 4. That's all right. Let's simplify this. That's 1 plus 2 times mu minus 1 minus 3 times mu and 3 plus 4 times mu. We get three equations: equation 1, equation 2, equation 3 from x, y, and z components respectively. Okay. Now, what do we get? What do we do for that? We just make two equations: 1 plus lambda, that equals 1 plus 2 mu. That's one equation. Then we have 2 minus 3 lambda equal to minus 1 minus 3 mu. We solve these two equations simultaneously. What do we get from that? Lambda equals 2 mu from the first equation. Put that in the other equation. You say, let's input lambda equals 2 mu there. What do we get from that? 2 minus 3 into 2 times mu equals minus 1 minus 3 mu. Let's solve this and see what that gives us. 2 minus 6 mu, that equals minus 1 minus 3 mu. And we get 3 mu equal to 3 and mu equals 1. That is the value of mu that I'm getting from this first equation. Now, let's put this value of mu in the first, from the second equation. Let's put this value of mu in the first equation, and that will give us lambda equal to 2 into 1. And the value of lambda turns out to be 2. So from the first and second equation, we are getting lambda equal to 2 and mu equal to 1. Now put these values in the third equation. If the third equation satisfies, that would mean that the lines intersect. If the third equation does not satisfy, that would mean that the lines do not intersect. So let's try that. Let's put these values in that third equation. The third equation is minus 2 plus 3 lambda equals 3 plus 4 times mu. This is equation number 3. Let's input lambda equal to 2 and mu equal to 1 in this. Minus 2 plus 3 into 2, that equals 3 plus 4 into 1. And that gives me 4 equal to 7, which is clearly not correct. So the third equation does not satisfy. Since the third equation does not satisfy, we say there are no values of lambda and mu that satisfy all three of these equations. What does that mean? That means lines AB and L, they do not intersect. If the third equation also satisfied, had also satisfied, we would have said that the lines intersect. In this case, they don't, because the third equation is not satisfied. All right. Yes. So this is also called skew lines. So when the lines do not intersect, when they're not parallel and do not intersect, we have another name for these lines, and that's called we say that these lines are skew lines. Yes. Sometimes they use that terminology as well. Pushpa, are you talking about vector AB or the line AB? This is the equation of the line AB. This is the vector AB. Vector AB is found by using OB minus OA, vector OB minus vector OA, position vector of the second point minus the position vector of the first point. This is the standard rule that we've got. AB vector, that's position vector of the second point, that means OB, minus the position vector of the first point. That's a basic vectors rule that you study in vectors. We also do this in O levels, by the way. In O level vectors as well, we learn about this relationship between a vector and its position vectors. So that's a general rule that we've got. If we had vector PQ, for instance, we would say OQ minus OB, right? Position vector of the second point minus the position vector of the first point. That's how you calculate a vector using the position vectors. Okay, all right. Let's move on to the second part. Now it says find the position vector of the foot of the perpendicular from A to L. This was a standard question on vectors. There was nothing different. So these are standard rules that we need to know about, okay? Standard methods that we need to know about. Finding points of intersection, finding whether lines intersect or are there skew lines, finding the length of the perpendicular from a point to a line, finding the foot of the perpendicular, finding angle between two vectors. These are 4 or 5 methods that just get repeated in vectors problems. You need to memorize the steps for this. This is very important. This is one topic in which I really recommend that you remember every single step. Okay, these are the steps that you're going to follow, because in every other paper you will see the same thing gets repeated. There's nothing new that they come up with in vectors generally. It's just the same thing repeating over and over again. How do we get the values of OB and OA? They are given in the question. This is OA, this is OB. That they're saying A and B have these position vectors. I've just written them in column vector form. Okay, they were given in the question. Okay, find the position vector of the foot of the perpendicular from A to L. Now, what does that mean? We've got a point A somewhere, and there's a line L. That line L is here, let's say. This point X is the foot of the perpendicular. We want to find the position vector of the foot of the perpendicular. Now we use the standard method that we brought for this. How do we start? We are going to use this idea that the vector AX is perpendicular to the line L, right? So first of all, we want to find the vector AX somehow. Now, what information do we have? We know the position vector of the point A. What's the position vector of the point A? That's given in the question. That says 1, 2, minus 2. That's OA. Let me write that here. 1, 2, minus 2. We've got the equation of the line L. Equation of the line L was given to be 1 minus 1, 3 plus mu into 2 minus 3 and 4. Right? These are the position vector and the equation of the line. Now, since point X lies on the line, what does that mean? What is the position vector of X going to look like? OX will be the same form as the equation of the line. So it would be 1 plus 2 mu. I'm just writing this in simplified form. Minus 1 minus 3 mu. 3 plus 4 times mu. That's OX, right? And the problem is we need to find out what the value of mu is. And then we would get that point OX. Now, how do you find the value of mu here? For that, we use this idea that AX vector is perpendicular to line L. How do you find the position? How do you find the vector AX? AX vector is equal to OX minus OA. We've written OX here. Let's subtract from that OA. 1 plus 2 mu minus 1 minus 3 mu 3 plus 4 times mu. Subtract from that OA, which is 1, 2, minus 2. The vector AX turns out to be vector AX turns out to be 1 minus 1, which is 0, 2 mu. Minus 1 minus 2 is minus 3, and then we have minus 3 mu. 3 minus minus 2, that's 3 plus 2, 5 plus 4 times mu. That's the vector AX. All right. We've got the line as well. Since the line is perpendicular to the vector AX, we can say the dot product of the vector AX and the direction vector of the line L. Remember, dot product only works for vectors. So we're not going to consider the whole line here. We're just going to consider the direction vector of the line. Direction vector of line is 2 minus 3, 4. We say the dot product of AX and the direction vector of L, that is supposed to equal 0. What's the vector AX? The vector AX is 2 mu minus 3 mu 5 plus 4 mu. Dot product of this with direction of the line, which is 2 minus 3 and 4. This should equal 0. Why? Because they're both perpendicular. We use this to find the value of mu. Let's find this dot product. 2 mu into 2 plus minus 3 mu into minus 3 plus 5 plus 4 mu into 4. All right, that's what we get. Now let's simplify this. Look out for careless errors here as well. 4 mu and then minus 3, that becomes plus 9. Minus 3 mu minus 3, that's plus 9 times mu. Plus 5 into 4, that is 20. And 4 mu into 4, that is 16 mu. And this gives us 16 plus 9, which is 25. 25 plus 4, that's 29. And getting 29 mu plus 29 equal to 0. So mu equals minus 1. Since the value of mu is negative 1, now what we can do is, since we were looking for the position vector of the foot of the perpendicular, we called the foot of the perpendicular x here. We have to find OX. Since the value of mu is negative 1, we can just input that value of mu in this equation, in this vector now to find the vector OX. 1 plus 2 mu minus 1 minus 3 mu and 3 plus 4 mu. Put that value of mu here, mu equals minus 1, and that gives you 1 plus 2 into minus 1 minus 1 minus 3 into minus 1, 3 plus 4 into minus 1, and that simplifies to minus 1, 2, and minus 1. That's the vector OX that we were looking for. It's minus 1, 2, and minus 1. That's the position vector. Now, since in the question they have used IJK form, it's better to write it in that form. It's not necessary though. You can also write it as minus I plus 2j minus k, and that's the final answer. You can leave it like this or like this. Both are acceptable. That's the position vector of the foot of the perpendicular. And that's what we were looking for. Make sense? Now, both of these parts were standard vectors problems. Those of you who had a problem with that, let me count how many were there. So that's 6 of you. If you had a problem with this question, both of these were standard vectors questions. That means there's something wrong with the concepts that you've learned, as in you're forgetting the concepts, or you have not done enough topical practice, because there's nothing new here. This is the same thing that's repeated in every other paper over and over again. So you need to understand these methods very well. Okay, so make sure to revise this topic, do more topicals for this, because both of these parts are very standard vectors parts. You'll see them again and again in topical course papers. Okay. All right. That was the last question from this paper. Now let's move on to the next paper. That's June 2023, paper 3, variant 3. Let's have a look at that other paper now. Okay, so this was June 23, paper 3.2. Let's start the other one. Again, have a look at the poll, have a look at the paper again, and then let me know the questions that you find difficult. The poll is posted in the WhatsApp group. Make sure to respond to that as soon as possible. So there are 3 questions that I see there from the other paper as of now. 8, 9, and 11. These are the questions that have the most number of votes. Let me have a look at question number 7 as well quickly, in case that looks difficult. We only need 3 votes for that. Yeah. This is the other variant now that we want to do. All right, let's try this now. June 2023, paper 3, variant 3. So as of now, I can see questions 8, 9, and 11 that have the most number of votes. Let me just go through the paper alongside as well. Okay, question number 1, that's pretty straightforward. 2 is just division. 3 is this locus again, we're done. Multiple questions like this before. 4 is this parametric differentiation. Okay. 5 is differentiation in the first part, and then iteration. Okay, 6 is trigonometry. That also looks relatively straightforward, or does it? Yeah, make sure to try this first part. It's slightly different from the way they ask it in standard questions. You'll first have to apply compound angle identity and expand this thing, simplify everything, and then after that convert it to this form. Okay, so try this. If you've not attempted this, yes, make sure to do it. It's not difficult, but it's just slightly different from the way they usually ask these questions. You'll first have to expand this and then apply the formulas for R and alpha. Okay, that's question number 6. This is the second part. Looks like a good one. Make sure to try this question if you haven't already attempted this. I see no votes for this, but I hope you have attempted this as well. Okay. For the no, we don't have that in our syllabus. If you have e raised to power x squared, you can't integrate it directly. You can only integrate it if you have this multiplied by x on the side. And in that case as well, they will give you a substitution. They will tell you some substitution. So in this case, they might tell you to use the substitution u equals x squared. And then you can do that. Otherwise, no. They can't ask you to integrate this thing directly. This thing, in fact, they won't ask you anyway. Okay. You can only have something linear in power of e. Question number 7. Okay, let's have a look at this. 7, and then 8, 9, and 11 after that. Or do we need to do it? Okay, so how many of you want to do question number 7? Can I raise the hands if you want to do question number 7? Okay, let's try this quickly. It looks like a standard substitution problem. So let's do this. Okay, so what's the substitution that we've got to use? This is the integration. It says sine of 2x e raised to the power 2 cos x we need to integrate this with respect to x. Limits are from 0 to pi. The substitution is u equals cos x. What do? We first of all have to differentiate it. And that gives us du over dx, which is minus sine x. Now we make dx the subject so that we can get rid of this dx from this integration. When we make dx the subject, that gives us dx equal to minus du over sine of x. Okay, this is one thing that we input there, and this is the other thing that we input there. Let's do this and see what that gives us. Okay, so we have a problem. We've got sine 2x here. We first need to apply double angle identity to expand it as well, because otherwise we can't use the substitution. We can use the substitution here, yes, but not here because we've got a double angle here. Let's expand that double angle first and see what that gives us. Sine 2x. How can that be written as? The double angle identity for sine 2x is 2 sine x into cos x. And then we have e raised to the power 2 cos x here with respect to x. Okay. Now, let's use that substitution. Cos x is going to be replaced with u. Sine x remains as it is. We can't do anything with that for now. Replace cos x with u, so it becomes u. Replace cos x with u here as well, it becomes e power 2u. Replace dx with this thing, and that becomes minus du over sine x. Okay. Now sine x and sine x, they get cancelled. And what are we left with? We've got this 2 here, and we've got this negative. If you want, you can write them outside to simplify things. Minus 2, or what have they done? Okay, they've left it inside. Let's actually leave it inside. Because of that, minus 2 u e raised to the power 2u du. All right, so we're done with the substitution part inside, but now we also need to change the limits. Limits for x were from 0 to pi. Let's find the limits for u. Let's see what they turn out to be. Write the upper limit separately and the lower limit separately. Upper limit and the lower limit. This is important. Otherwise, you can end up mixing them up sometimes. Upper limit originally was pi. So we say x equals pi was the upper limit and x equals 0 was the lower limit. U equals cos x. So that means u equals cos of pi. What is cos of pi? Cos of pi is minus 1. And then u equals cos of 0. Cos of 0 is plus 1. Now that means upper limit is minus 1. So this upper limit is going to be minus 1 and the lower limit is going to be plus 1. So the upper limit is smaller value here and the lower limit is the bigger value here. But in the form that we want at the end, they have converted it to the standard form in which upper limit is on the bigger value is the upper limit and the smaller value is the lower limit. So if we want to switch limits, what do we do for that? We multiply the function by negative and the limits get switched. If you want to switch limits like this, we say this negative sign gets removed and we have 2u e raised to power 2u with respect to u. And that's what we wanted to do. You've shown this thing, all right? This integral that converts to this form when you do substitution. All right, so this part is done. Now they say, hence find the exact value of that integral that they are given. We have already converted it to this form, 2u e raised to power 2u with respect to u with limits minus 1 to 1. This is the form that we've gotten up after substitution. Now we just need to integrate this. How do we integrate this? This is a simple integration by parts problem. You have to use integration by parts. How do you decide? So remember the integration by parts rule. uv dash integral of that is given by uv minus integration of vu dash. Right? Now in this case, what is going to be u and what is going to be e power 2u? What's going to be v dash? Let's decide that using ILATE. Which two functions do we do we have here? We've got an algebraic function, that's u, and we've got an exponential function, that is e. Whatever is on the left side, we take that as u. Whatever is on the right side, we take that as v dash. Okay. Now, in ILATE, algebraic is on the left side, so we take that as u. So basically, u is going to be taken as u. Okay, so u is u. And what about v dash? V dash is going to be e power 2u. That's v dash. Now, what is u dash? U dash is going to be 1. Derivative of u, that's 1. We have to integrate this. What's the integration of this? To get v, that gives us e power 2u divided by 2. Derivative of 2u, that's what you get in the denominator. You've got everything that you need now. Let's apply that rule. This 2 can just be written outside. I'm not considering 2 here because 2 is just a constant. I can just write that outside the integral. You have to do that in this step already. 2 is just a constant multiplying. It's okay to write that outside the integral like that. So I've just written that 2 outside. And I'm just focusing on integrating u and e power 2u. Okay? Now let's apply that rule. What does that rule say? uv minus integral of v dash. Okay, so u remains as it is. That's u into v dash, which is e raised to power 2u divided by 2. Minus integration of vu dash, that means e power 2u over 2, multiplied by u dash, which is 1. This is what you've got now. We need to integrate this with respect to u now. Let's simplify this. 2 into u e raised to power 2u divided by 2 minus. This 2 can be written outside the integral. And inside, we are just left with integration of e power 2u. How do you integrate e power 2u? Integration of e power 2u would be e power 2u divided by 2. And now the integration is done. Let's simplify this a bit. u e raised to power 2u divided by 2 minus 1 over 4 e raised to power 2u. And now you input the limits. What were the limits? Limits were supposed to be from minus 1 to 1. So we input minus 1 and then we input plus 1 and then subtract those two cases. 2 multiplied by 1 e raised to power 2 into 1 divided by 2 minus 1 over 4 into e raised to power 2 into 1. Subtract from this the case when you input u equals minus 1, and that gives you minus 1 e raised to power 2 into minus 1 divided by 2 minus 1 over 4 e raised to power 2 into minus 1. Now simplify everything. We want an exact answer. Yeah. So you want an exact answer. You can't put this whole thing on a calculator. You have to show steps and write down the exact value at the end. So this becomes 2 into e square over 2. You can just do that simplification as well. 2e squared over 2 minus 2 over 4e squared. Minus and minus, that becomes plus e raised to power negative 2 over 2 plus 1 over 4 e raised to power negative 2. Let's simplify this. This 2 and 2, they get cancelled. 2 and 4, they leave us with 1 over 2. So e squared minus half e squared, that's going to give us 1 over 2 e squared, half e squared, right? And then these two terms are also the same. Half e raised to power minus 2 plus 1 over 4 e raised to power minus 2. That's 2 over 4 plus 1 over 4. That will be 3 over 4. So we have 3 over 4 e raised to power minus 2. And that's the final result that we get from this. 1 over 2 e squared plus 3 over 4 e raised to power negative 2. Does that make sense, Pedro? That's the exact result that we get. Any problems? No? Okay, let's move on to the next one now. So the next one that you're asking about is question number 8. Right? Question number 8 from this paper. Let's have a look at this. After this, we have 9 and 11. Okay. Question number 8. Let's try this. It says the variables x and y satisfy this differential equation for x greater than 0. It's given that x equals 4 when y equals 2 under root 3. Solve the differential equation to obtain the value of x when y equals 2. Now, how do you solve differential equations again? We separate the variables, integrate both sides. We want y terms on the left side, x terms on the right side. How can we do that? Let's bring y plus 4 to the left side. That becomes y plus 4. And then bring y squared plus 4 in the denominator here. Then we have dy here. On the right side, we're left with just 1 over x and dx. Okay, so variables are separated. X terms on the right side, y terms on the left side, dy on the left, dx on the right. Let's integrate both sides now. Now, the right side is pretty straightforward. What's the integration of 1 over x? That's ln of x plus c. If you just do this, you get 2 out of 8 marks already. 1 mark for separating the variables and 1 mark for this integration. Okay. So why am I telling this? If you don't understand something in a particular question, don't just leave it blank. Just try to do something at least. Or if you're running out of time, let's say, just writing these 2 things will give you 2 marks already. Okay, and that's pretty quick. So don't leave everything like that. Okay, now what about the integration of the first part? How do you integrate this part? Y plus 4 over y squared plus 4. It's again a fraction. How do we integrate fractions? We've got multiple rules for that. Ln rule, tan inverse rule, partial fractions, and some other rules as well. Ln rule, does that work? The derivative of denominator is 2y. The problem is we also have a constant here. That's not going to work. Tan inverse form is this is not the tan inverse form, because for that we need a constant in the numerator. You can't find partial fractions because in the denominator you can't factorize this thing. What else? Can we split the numerator? Yes, so that's what we can do here. We can split the numerator and write it as 2 separate fractions. We can say this can be written as y over y squared plus 4 plus 4 over y squared plus 4. We can write this as 2 separate fractions like this, splitting the numerator. Okay, and now we can integrate each of these fractions separately with respect to y. Now, what about the first one? The first one we can integrate using the ln rule now. What's the derivative of the denominator? 2y. Now we can have 2y in the numerator. We can just multiply by 2 inside, and to balance that, divide by 2 outside. And now this is the standard ln form. Derivative of the denominator is appearing in the numerator now. So this integrates to 1 over 2 into ln of y squared plus 4. Fardeen, think again. Okay, what about this? 4 over y squared plus 4. How do we integrate this? Which form is this? This is tan inverse form. Constant in the numerator. In the denominator, you've got a square term, a constant term, and plus between them. That's the form that we have for tan inverse. What we can do is we can write it like this. Write 4 outside. It's not necessary, but if you want to convert it to exactly that form, you can write it outside and have 1 inside. And in the denominator, you would have y squared plus 2 squared. Okay. And now this becomes, keep writing the right side as it is, ln x plus c. The first integral is already done, y squared plus 4. Now, what about the second one? This is tan inverse form. In place of a, you've got 2 here. Coefficient of y squared is already 1. What is this going to integrate to? 1 over a, that means 1 over 2 into tan inverse of y over a, which is y over 2. On the right side, you've got ln x plus c. Now 4 and 2, they get cancelled, and we have 2 here. This is the integration part done. Okay, now we need to find the value of c, and then find the value of x when y equals 2. That's what they're asking for. We'll do that in a moment. So that's the integration part done. This much should get you, I think, around 4 or 5 marks. Yeah, 4 marks. Maybe, most likely. But maybe 5 until this point, okay? Fardeen, y square minus 4 is y plus 2 into y minus 2. Y square plus 4 cannot be factorized. A square, it's a square minus b square, not a square plus b square, okay? All right. Now, let's find the value of c. Let's put x equals 4 and y equals 2 under root 3. What does that give us? 1 over 2 into ln of 2 under root 3 whole squared plus 4 plus 2 into tan inverse of 2 under root 3 over 2 equals ln of 4 plus c. Okay. Now, since you want the value of x, and they have not specified that you want an exact answer, you could write decimals as well. Although for c, generally we prefer not writing decimals. So let's actually leave it in exact form for now and see what we get from that. 2 tan inverse of 2 under root 3 over 2. It's fine until this point. Okay, so this looks correct. Just look out for any careless errors. I was just looking at that. 1 over 2 into ln of 4 into 3, that's 12, plus 4, that will be 16. Half ln 16 plus 2 into tan inverse of under root 3. What's that? Tan inverse of under root 3, that is pi over 3. That equals ln of 4 plus c. Okay. And from that we get c equal to ln 4. If you think about it, this can actually be written as ln of 4 as well. 1 over 2, this can go to the power, go as power here. So it becomes ln of 16 power 1 over 2 plus 2 pi over 3 plus equals ln 4 plus c. This is also ln 4, this is also ln 4, and that gives us c equal to 2 pi over 3. All right, so we've got the value of c from that. Once we've got the value of c, now we put this back in this equation. That equation becomes 1 over 2 into ln of y square plus 4, that plus 2 tan inverse of y over 2. That equals ln of x plus c, which is 2 pi over 3. Okay, now what are we looking for? We're looking for the value of x when y equals 2. Now put y equal to 2 here to get the corresponding value of x. Yeah. What do we get? 1 over 2 into ln of 2 squared plus 4 plus 2 tan inverse of 2 over 2 equals ln x plus 2 pi over 3. What does that give us? Half ln of 8 plus 2 tan inverse of 1. What's tan inverse of 1? I think it's pi over 4, right? Or you can just put this on your calculator, pi over 4. 2 pi over 4. On the other side, you've got ln of x plus 2 pi over 3. And now, just take everything to the other side and see what value of x you get from that. One over 2, that's ln of 8 divided by 2 plus 2 pi divided by 3, sorry, divided by 4 minus 2 pi divided by 3. So I'm getting ln x equal to 0.51612. And now the base of ln is e. E will go to the other side, become the base of 0.51612. And that should give you the result. You can see what that turns out to be. E raised to the power answer. And that's giving me 1.67. 1.6755. If you want to round it off, that'll actually get rounded off to 1.68. And that's the final result. X equals 1.68. That is what we were looking for. Since they did not want an exact answer, we can just write decimals there, and that's okay. X equals 1.68. Is that okay? So here the base of ln was e. I just took that e to the other side, made that the base of that number on the right side in power form, and that's what we get. X equals 1.68. Make sense to everyone? Any problems with this? Okay, let's move on to the next one now. Question number 9. Okay, again, vectors. Okay, now this looks different from the standard question. Let's have a look at this now. It says the lines L and M have these equations. Relative to the origin O, the position vector of the point P is 4i plus 7j minus 2k. So we've got this point P, the position vector of the point P, OP, that is 4, 7, and minus 2. And the position vector of, we have the lines equations as well. Given that L is perpendicular to M and that P lies on L, find the values of the constants A, B, and C. Okay, lines L and M are perpendicular to each other. Okay, now if two lines are perpendicular, that means their direction vectors are supposed to be perpendicular, right? Because perpendicular has something to do with the angle of those lines. Angles come from the direction vectors. Okay, whenever we talk about two lines being perpendicular, we're basically saying their direction vectors are supposed to be perpendicular. What are the directions of the line? Let's write them in vector form and the column vector form. They are C minus 2, 4, and 2 minus 3 and 1. Since they are both perpendicular, the dot product of their direction vectors, that should be equal to 0. What do we get from this? 2c minus 2 into minus c, that's 6, plus 6 plus 4, that equals 0. And that gives us the value of c, which is minus 5. So we get the value of c from this using that both the lines are perpendicular. That's one thing. And now it says point P lies on L. What's the equation of the line L? The equation of the line L is this. It's R equals, let's write this in column form again. It's A, 3, and B plus lambda into C. We've got the value of C now. The value of C is minus 5, minus 2, and 4. This is the equation of the line L. Since the point P lies on L, if we were to input that point P in this equation should satisfy, right? If you were to input the position vector of P inside this line, this equation should be satisfied by that. Let's do that. Let's put that point here. What's the point? Let's equate it to that point, 4, 7, minus 2. And in place of R, we input that point. On the right side, let's simplify this. We have A minus 5 lambda, 3 minus 2 lambda, and B plus 4 lambda. Just equate them and see what that gives you. A minus 5 lambda equals 4. That's one equation. 3 minus 2 lambda equals 7. And b plus 4 lambda equals minus 2. Let's find the value of lambda from the middle one, because there we only have one unknown, that's lambda. What does that turn out to be? Lambda here turns out to be minus 4 over 2, which is the minus 2. Put that value of lambda here and here, and that will give you the value of a and b. A minus 5 into minus 2, that equals 4. The value of a turns out to be, let me do one more step. A plus 10 equals 4. That means a equals minus 6. And then in the other equation, b plus 4 into minus 2, that equals minus 2. That means b minus 8 equals minus 2. And the value of b turns out to be plus 6. So a equals minus 6, b equals 6, and the value of c equals minus 5. These were the three values that we were looking for. Okay? We got the values of a, b, and c. That was the first part. So for a and b, we just put that point P inside this equation. All right. Okay. Now, let's look at the next part. Next part says the perpendicular. Why we're doing this, by the way, just a reminder. What does this R represent? R basically represents X, Y, Z. Right? Just like in a straight line equation in 2D form. Let's say you have 2x plus 5 here. X and Y are representing every single point on the line. So R here is basically X, Y, Z. It represents every single point on the line. So if P lies on this line, in place of X, Y, and Z, we basically just put these values. Okay? All right, good. Let's have a look at the next part now. Now it says the perpendicular from P meets the line M at Q. The point R lies on PQ extended, with PQ ratio QR being 2:3. Find the position vector of R. Okay, now how do you think about this? Perpendicular from P meets the line M at Q. Okay. So we have a point P somewhere. Let's say this is point P. Do we know the position vector of the point P? 4, 7, and minus 2. That's the position vector of P. 4, 7, minus 2. And then we've got the line M. The line M has this equation. Let me write that down here as well. R equals one, 2, 3 plus mu into 2 minus 3, 1. 2 minus 3 and 1. That's the line N. And now they're saying the perpendicular from P meets the line M at Q. So if you were to make a perpendicular from P to the line M, this point here, the foot of the perpendicular, they're calling this point Q. And now they're saying the point R lies on PQ extended, such that PQ ratio QR is 2:3. Okay, so basically, if you were to extend this line further, at some point you've got another point that's R, and that is such that if this was 2 units, this would be 3 units. That's what they're saying. Okay? If PQ was 2 units, QR would be 3 units. And now, based on this information, we need to find the position vector of R. Now, how do we do this? First of all, we have to find the position vector of the point Q. Once we have the position vector of the point Q, we can use ratios after that to figure out the point R as well. Okay, so we need to start by finding the position vector of the point Q first of all. How do we do that? Let's think about this. Okay, let's find the position vector of the point Q and see what that turns out to be. It's the same process that we did for the earlier question, the vector question in the last paper as well. Let's follow that same process again quickly. First of all, we need to find the vector PQ somehow. How do you find the vector PQ? For that, we need OP and OQ. OP is already given. What's OQ? OQ is going to be of the same form as the equation of the line. Since OQ lies on the line M, the position vector of Q is going to be the same as this line because it lies on this line. It's just that we don't know what the value of mu is. So we write this in terms of mu. It turns out to be 1 plus 2 mu, 2 minus 3 mu, and 3 plus mu. That's the vector OQ. Okay. And now let's find the vector PQ. What would that be? PQ would be OQ minus OP. So from this vector, I'm subtracting this vector. Let me do that directly now. 1 minus 4, that will be minus 3 plus 2 mu. This minus 7. 2 minus 7 is minus 5 minus 3 mu. 3 minus minus 2, that's 3 plus 2, that's 5 plus mu. This is the vector PQ. And now since PQ is supposed to be perpendicular to the line M, what we can do now is we can put the dot product of PQ, that's minus 3 plus 2 mu minus 5 minus 3 mu, 5 plus mu. Dot product of this with the direction vector of the line M, that's this. So basically we're using this vector here, the direction of line M, and the vector PQ. Their dot product is supposed to be 0 because they're perpendicular to each other. 2 minus 3, 1, that's the direction vector of the line M. Their dot product has to equal 0. Okay, let's find this dot product. Minus 3 into 2, that is going to give us minus 6. 2 mu into 2, that is 4 mu. Minus 5 into minus 3, that's plus 15. And then we have plus 9 mu plus 5 plus mu. This equals 0. Let's simplify this and find the value of mu from this and see what that turns out to be. We get 14 times mu and 20 minus 6, that's also 14, plus 14 equals 0, and the value of mu turns out to be negative 1. We found the value of mu. We can use this now to find the position vector of the point Q. This is OQ. Let's write down that position vector. So in place of mu, we have to input negative 1. Okay, so what does this become? Let me just write it here. 1 plus 2 into minus 1, 2 minus 3 into minus 1, and 3 minus 1. That will be 1 minus 2, which is minus 1. 2 plus 3, that's 5. And 3 minus 1, that's 2. So the position vector of Q turns out to be this. We've got the vector OQ. All right. So we have OP and we've got OQ. Now we need to find the vector OR somehow. How do we do that? Let's think about this. Let me write this here now. So there could be another formal way of doing this, but you cannot actually just think of it logically. Let me explain how. Let me write it like this to save some space. OP, that vector OP is given by 4, 7 minus 2. And then you have OQ. OQ is minus 1, 5, and 2. How do we go from P to Q? In order to go from P to Q, how many units do we have to go here? -5 units, right? 4 to -1. How do we go from 4 to -1? We have to subtract 5 units for that. In order to go from 4 to -1, we have to go -5 units. Okay. You in PQ? Why would we do that? If we put mu in PQ, that is going to be used for finding the length of PQ, but we don't need that. We want the position vector of R. We're looking for this point R. So what you are saying is that's used for finding the distance PQ, that we put mu in PQ and then find the modulus of that, magnitude of that to find the distance of P from Q. That's not what we're looking for. We're looking for the position vector of point R. And that's this one. We've got point P and point Q now. How do we go from P to Q? In order to go from P to Q, we have to go -5 units, right? And then in order to go from 7 to 5, we have to go -2 units. In order to go from -2 to 2, we have to go +4 units. And they are saying distance from P to Q is basically 2 if the distance from Q to R is 3. So basically, the ratio between these distances is 2:3. So if this gap is 2 units, this gap is supposed to be how much? 3 units. Or if this gap was 1 unit, this gap is 1.5 units. So essentially, whatever is the gap earlier, you just multiply that by 1.5. So in order to get to point R now, what you have to do is -5 into 1.5, that's -7.5. -2 into 1.5, that's -3. And then 4 into 1.5, that's +6. You have to go this many units more to get to the point R. And that point R, therefore, would be -1 minus 7.5, that is -8.5. -2 minus 3, that is -5. And 2 plus 6, that is 8. This should be the position vector of the point R. Okay, sorry, 5 minus 3, that is actually, this was 5 minus 3, that's actually 2. -8.5, let me check this again, -1 minus 7.5, that's -8.5. And then 5 minus 3, that's 2. 2 plus 6, that's 8. And that is the result that we get from this. This is one way to think about this. If you understand this, that's great. It requires a lot of thinking. The other possibility is slightly simpler to understand. Let me actually explain that as well now. Since PQ ratio QR is 2:3, we could also do something like this. We could say the vector PQ and the vector QR, let's connect both of them. How can you connect both of them? PQ and QR. If the ratio is 2:3, we could write it like this. We could say PQ over QR, that equals 2/3. And if we cross multiply, that gives us 3PQ equals 2QR. If this is the ratio of their magnitudes, it would be the same ratio for their vectors as well. So we could say 3 into PQ vector, that would be equal to 2 times QR vector. And now, since we already have PQ vector here, that's here. Let's see what this turns out to be. If mu is -1, what do we get for that? -3 -2, -5 plus 3, and 5 minus 1. That will be -5. So this vector is -5 -2, and 4. -5, -2, and 4. That equals 2 into QR vector. Now we don't know what QR vector is. In place of QR, what we can do is we can say QR is the same thing as OR minus OQ. And now on the left side, we've got -15, -6, and 12. On the right side, we have 2 into OR. OR is what we have to find out. -2 into OQ. What's OQ? OQ we already know. OQ is this vector. What was this? We found this here as well. -1, 5, and 2. -1, 5, and 2. -1, 5, and 2. And now we can find OR from this. Let's see what that's going to be. -15, -6, 12. Let's bring this to the other side. It becomes +2 into -1, 5, 2. That equals 2 into OR vector. Now this becomes -17, 4, and 14 on the other side. Sorry, that's not correct. -6 plus -6 plus 10. That's 4. That's correct. This was 12. You can write this clearly. 12 plus 2 into 2, that will be 16. Yes, that's also correct. On the right side, we've got 2 into OR vector. Now divide the other side by 2. So we have 1 over 2 times this now. And that will give us the vector OR, which turns out to be -8.5, 2, and 8. And that's the same thing that we got there as well. That's the vector OR. That's another way to think about this. Properly using vectors. This was how you could do it mentally. That will require less working, but you can do it both ways. Does that make sense? So let me repeat that earlier method again as well. So basically the ratio was 2:3. 2:3 means it's 1:1.5. So basically what we did in that earlier method was we said if the gap between P and Q is 1 unit, the gap between Q and R would be 1.5 times that. So whatever was gap between P and Q here, we just multiplied those gaps by 1.5. And they turned out to be -7.5, -3, and +6. I just multiplied all of them with 1.5. So basically, -5 into 1.5, that's -7.5. -2 into 1.5, that's -3. 4 into 1.5, that's 6. And then we just said -1 -7.5, that gives us -8.5. 5 -3, that gives us 2. And 2 plus 6 gives us 8. And then that got us to that final point that we were looking for. Is that okay? It was this part was quite complicated, but 4 out of those 6 marks were basically for finding the point Q. Once you find the point Q, I think most likely you have just 2 marks for getting the final answer. Or you would at least get 3 marks, if not 4, until this point. Or most likely 4, and there'll be 2 marks for this. This much every one of you should be able to do. But then this will require some thinking. Quite a lot of thinking. Is that okay? Make sense to everyone? Can we move on to the last question then? All right, good. The last one is kind of straightforward. Let's do 11. That's the last question that you asked about. The complex number is z is defined by this, where a is an integer. It's given that argument of z is -5/4. Find the value of a, and hence express z in the form x plus y iota, where x and y are real. Okay. So argument of z is given to be minus pi over 4. Let's think about that. In which quadrant is that going to be? Minus pi over 4 argument, negative argument, acute. That's going to be here in the fourth quadrant. So this point z is going to be here in the fourth quadrant. And now what's the angle? Minus pi over 4. Now that's an important angle. This angle is pi over 4. Pi over 4 means 45 degrees. What that means is the real part of this point z, this is the real axis, this is the imaginary axis. Since the angle is pi over 4, whatever is the real part here and whatever is the imaginary part here, their magnitudes are supposed to be equal to each other, right? Because it's a pi over 4 line, 45 degree line. 45 degree line means this triangle would be an isosceles triangle. Opposite sides are equal. This side and this side, they're equal to each other. So the real part and imaginary part, in terms of magnitude, they will be equal to each other. Make sense? The real part and imaginary part of z, they should be equal to each other. Okay, now keep that in mind. And now we can see how we can actually figure this out. Let's first of all convert it to the standard form. This is a fraction. How do we get rid of this fraction? What's the standard rule for that? We multiply and divide by the conjugate of the denominator. So we multiply by 3 minus a iota and also divide by 3 minus a iota. Let's first convert it to this form, x plus y iota form. And then what we do is we say, whatever is the real part, it should be the same as the imaginary part. It's just that the real part will be positive, imaginary part will be negative. Okay, they'll be equal to each other because the angle is pi over 4. Okay, now let's simplify this first. In the numerator, we get 5a into 3, that's 15 times a. 5a into minus a iota, that's minus 5a squared iota, minus 6 iota, plus 2a iota squared, whole divided by 3 plus a iota into 3 minus a iota, that's a plus b into a minus b. We can say that's 3 squared minus a iota squared. Let's simplify this further. We get 15a minus 5a squared iota minus 6 iota plus 2a into minus 1. In the denominator, we get 9 minus a squared iota squared. Let's simplify this further. In the numerator, we get 13 times a minus 5a squared into iota, or we can write the iota terms together as well now. We say it's minus into 5a squared plus 6 into iota, 4 divided by 9 minus a squared into minus 1. And that gives us, if you were to split the real part and imaginary part as well now, we get 13a over, this is going to be 9 plus a squared, 13a over 9 plus a squared, minus 5a squared plus 6 over 9 plus a squared, whole multiplied by iota. This is what we get when we simplify this whole thing. We have this real part and this imaginary part. All right, we have gotten rid of iota from the denominator now, and now this is the standard form x plus y iota. Now, since we were given that the argument is minus pi over 4, what we can do is we can say, since the argument is minus pi over 4, the real part, whatever that real part is, and the imaginary part, they are the same. It's just that the imaginary part is negative. So these two things are going to be equal to each other. These two will be equal to each other. What does that give us? That gives us 13a over 9 plus a squared equal to 5a squared plus 6 divided by 9 plus a squared. The denominators get cancelled and we're left with 13a equals 5a squared plus 6. We can solve this quadratic equation. 5a squared minus 13a plus 6 equals 0. Can we factorize this? We need to have 30, and by adding, so we can use 10 and 3. 5a squared minus 10a minus 3a plus 6 equals 0. That gives us 5a minus 3 as one factor and a minus 2 as the other factor. A equals 3 over 5 or a equals 2. These are the two values of a that I'm getting. But the question says find the value of a. That means we can't have multiple values. We only are going to have one value. Let's see what value we can use. Yeah, so the question says a is an integer. So a is supposed to be equal to 2. This is the value that we use. This is not an integer. So we ignore this. That's the value of a that we've got. A equals 2. And now we need to convert, we need to write z in this form, x plus y iota form. How do we do that? Z equals 13 times a, that's 13 into 2, divided by 9 plus 2 squared minus 5 into 2 squared plus 6 divided by 9 plus 2 squared iota. What do we get from this? 26 divided by 13, and that's going to be 2. 2 minus 20 plus 6, that's 26, divided by that. That's 2 minus 2 iota. That is what z turns out to be. 2 minus 2 iota. Make sense to everyone?
Sir, sir, if angle was not pi over 4, will we still put it equal to each other?
No.
The
How can we do that in that case? It's only because angle is pi over 4, because if angle is pi over 4, that means it's a triangle like this, in which this angle is pi over 4, this is pi over 2, this is pi over 4. So the sides opposite to pi over 4, they're supposed to be equal. So this side and this side, they're the same. That's why we're putting them equal to each other. Otherwise, we can't do that.
Sir, is there any case where the angle is not pi over 4?
It is possible. Then you have to use sine, cos, tan ratios, but that will be too complicated.
Okay, sir. Okay. Thank you.
Okay. All right, let's look at the next part now. Now it says express z cube in the form r e raised to power iota theta, where r is greater than 0, theta is between minus pi and pi. Give the simplified exact values of r and 0. Okay, so how do we think about this now? Z equals 2 minus 2 iota. First of all, let's write z in r e raised to power iota theta form. What's r? R is 2 squared plus 2 squared, square root of that is going to be square root of 8. And they want simplified exact values. If you put this on your calculator, put square root of 8 on your calculator, you'll get 2 under root 2. This is the simplified exact value. Square root of 8 is not simplified. 2 under root 2 is what is the simplified form. That's r. And then what about the angle? Theta. What was that? Theta was minus pi over 4. That's already given. You don't have to calculate that again. It was given in the question. So that means z is basically 2 under root 2 e raised to power minus pi over 4 iota. That's what z is. What about z cube then? Let's take cube on both sides, and that gives us 2 under root 2 e raised to power minus pi over 4 iota whole cube. What do we get from that? 2 under root 2 cube of that. That is 16 under root 2. Power gets multiplied with the power of e here, and that gives us e raised to power minus 3 pi over 4 iota. But now the problem is, we want the angle to be between minus pi and pi, that is between minus pi and pi. So we can actually just leave it like this, and that's our final answer. This is what we get, right? 16 under root 2 into e raised to power minus 3 pi over 4. Make sense? That's part B. That was pretty straightforward. Any questions on this? No? So these were easy 3 marks. The first part was relatively more complicated. And that's it. That's all the difficult questions done from this paper. I hope that was helpful. If you have any quick questions, let me know. Otherwise, we end this here. No problems, anyone?
No, sir.
Laiba, is that what you're asking for? Okay, makes sense. All right, good. So we end this here then. We will have our next P3 class on Thursday now. We will not have it on Wednesday because of the P1 exam, but then we will have a class on Thursday and Friday and possibly Saturday as well. So 3 classes next week. And then from Thursday onward, we have classes every day of the week. Basically all weekdays after that. All right. From Thursday onward, we will have almost daily classes all weekdays. Okay, because on Thursday we will be done with paper 1 exam, and then we'll be having the 5 p.m. to 7 p.m. start only for paper 3. All right, that's it for today. I'll see you again in the next class. Allah Hafiz.
Allah Hafiz, sir.